Everyone, so we are here with the practice set 2.1 standard 10th algebra. So the first question they have asked is write any two quadratic equations. So this is an open-ended questions. So you can write your own, like I am writing x square plus 5x plus 6 equals to 0. Okay, and second one I'll be writing, let us say uh, 3y square minus 14 equals to 0. Okay, you can have b as 0. Okay, so this is the general form of the quadratic equation, ax square plus bx plus c equals to 0. Okay, now here either a, b or c can be 0. Okay, so when I am writing ax square plus bx plus c equals to 0, that means if I take a as 0, okay, so it will be bx plus c equals to 0 because this will become 0. So I cannot call it a quadratic equation, okay, because the condition for an equation to be quadratic is a degree should be 2. Let us say if b is equal to 0. So this will become 0. So what will remain? Ax square plus c equals to 0, which is a quadratic equation. Okay, as this is not a quadratic equation, so let us say if c is equal to 0. So what will remain? Ax square plus bx equals to 0. Still it is a quadratic equation because the degree is 2. Okay, so this is not, and this is a quadratic equation. So your condition is c can be 0 or b can be 0, but a should not be equal to 0. Okay, then. Okay, so children, you can see x square plus 5x minus 2 equals to 0. They have asked to check whether it is a quadratic equation or no. Okay, so here the highest index is 2. Therefore, the given equation is a quadratic equation. Okay, then here again you can see, if I take this here, y square minus 5y plus 10 equals to 0. Here also the highest index is 2. Therefore, the given equation is a quadratic equation. Okay, that is why I have not given you any introduction, because in 2.1 itself you will understand what are quadratic equations and how we have to classify them. Okay, now here you are getting a term in a fraction form where y is in the denominator. In such a case, you have to multiply the whole equation by the same, because I want to cut y. I don't want y. So what will I do? Multiplying by y. If I multiply the whole equation by y, this will become y cube, this will become 1 because y will get cancelled, and this will become 2y. Sorry. Okay, so I'll take here, therefore y cube minus 2y plus 1 equals to 0. Sorry, this is 3. This was 3y cube minus 2y plus 1 equals to 0. Now, as you can see, the highest index is 3. Therefore, the given equation is not a quadratic equation. Quadratic equation means the highest power has to be 2, not more than 2, okay, or not less than 2, okay. Then, so we'll move on to fourth one, which says x plus 1 upon x is equal to minus 2. So I don't want x, so what will I do? Multiply by x. The whole equation I'll multiply by x. So this will become x square plus 1 upon x into x will become x. Okay, sorry, this will become 1 as x will get cancelled, and this will become minus 2x. Okay, so if I arrange this, we'll get x square plus 2x plus 1 equals to 0. Okay, so as you can see, the highest degree is 2, so you will just write that it is a quadratic equation. Okay, due to space constraints, I am not writing here now, but you can see it is a quadratic equation. Let us solve this. We have to solve this to find out fifth one is a quadratic equation or no. So m minus 5 plus 2 m minus 5. Okay, then this will become m square minus 5m plus 2m minus 10. Okay, so now this is m square minus 5m plus 2m becomes minus 3m minus 10 equals to 0. Okay, so you can see the highest degree is 2, highest index is 2, so you can write therefore it is a quadratic equation. I am just putting a tick for your better understanding. It is a quadratic equation. Okay, now this one I'll solve this. This is m cube plus 3m square I'll take here. It will become minus 3m cube plus 3m square is already here in LHS, minus 2 equals to 0. Okay, now this becomes minus 2m cube plus this becomes 3m square minus 2 equals to 0. Okay, so here you can see the highest index is what? The highest index is 3. Okay, so it is not a quadratic equation. You have to write this in statement. Okay, so the given equation is not a quadratic equation. Okay, then we'll move on to question number 3. Question number 3, we have to compare the equations with ax square plus bx plus c, which is the standard form of the equation, and we have to write abc. So let us first write this in this form. This is the standard form. I'll write here standard form of quadratic equation. What is the standard form? Ax square plus bx plus c equals to 0. Okay, every equation, quadratic equation, if you are asked to write it in standard form, you have to write it like this. Now here you can see y is here in LHS. C and B, C and A are in RHS. So I'll arrange in this form. So y minus y square, if I bring here, it will become y square plus 2y already in LHS. So it will be plus 2y. 10 will come here, it will become minus 10 equals to 0. Okay, so y square plus 2y minus 10 equals to 0. Now, comparing the equation with, you have to compare this with ax square plus bx plus c equals to 0. What will you get? You will get a equals to, here this is x square plus bx plus c, a equals to 1, b equals to what? B equals to 2 and c equals to minus 10. Okay, let us come here. X minus 1 the whole square equals to 2x plus 3. You know the expansion of this is x square minus a square minus 2ab plus b square. Okay, you know the expansion of this, a square minus 2ab, 2 into x into 1 will be 2x, plus b square plus 1 square is 1, equals to 2x plus 3. Okay, now if you observe, I'll arrange it further. X square minus 2x plus 2x, I'll bring it here, it will again become minus 2x plus 1, 3 I'll bring it here, minus 3 equals to 0. So you got x square minus 4x minus 2 equals to 0. Okay, so you got a equals to 1, b equals to minus 4, c equals to minus 2. Okay, as you can see, comparing the equation with this. So with this we have done our second one. Let us do our third one. X square plus 5x, on opening the bracket this will become minus 3 and this will become plus x. Okay, solving it further, it will be x square plus 5x, everything I am bringing into LHS. So plus x will become minus x and minus 3 will become plus 3 equals to 0. So this further will become x square plus 5 minus 1 is plus 4x plus 3 equals to 0. So we'll write, comparing the equation with ax square plus bx plus c equals to 0. A equals to 1, b equals to 4 and c equals to 3. Okay, here you can see 3m square minus 2m square plus 9 equals to 0. Okay, so this will become m square, 3 minus 2 is 1, m square plus 9 equals to 0. Okay, so comparing with ax square plus bx plus c, I'll get a equals to 1, b is not there, so b equals to 0 and c is what? C is 9. Okay, then we'll move on to fifth one. So coming on to fifth one, here we have to multiply the bracket. This becomes 3p plus this becomes 6p square equals to minus 5. So I'll arrange this in the standard form. 6x square plus 3p minus 5 will come here. It will become plus 5 equals to 0. Now comparing the equation with ax square plus bx plus c equals to 0, we'll get a equals to 6, b equals to 3 and c equals to 5. Okay, here very simple, x square minus 9 minus 13 equals to 0. 13 will come in LHS, it will become minus 13. So x square, this will become minus 22 equals to 0. Okay, now comparing with ax square plus bx plus c equals to 0, we'll get a equals to 1, b is not there, so of course b will be 0 and c is what? Minus 22. Okay, then now question 4th says that x square plus 4x minus 5 equals to 0. Okay, in that we have sub question 1 and we have to check that the values given against them are the roots of quadratic equation or no. So in that case what can we do? Substituting x is equal to 1. We are taking here only LHS. Okay, now LHS is this, x square plus 4x minus 5. Okay, equals to, because we are taking x as 1, this will become 1 square plus 4 into 1 minus 5. So it will be 1 plus 5 plus 4 minus 5. So it will be 5 minus 5, which is equal to 0. Okay, that means that x equals to 1 is the root of quadratic equation. Understood? Now if we take substitute the value of x and we get RHS as 0, we are coming here, then the value is the root of the quadratic equation. Now let us try with this, the other value, substituting x equals to minus 1. Only LHS will take x square plus 4x minus 5. So this becomes minus 1 square plus this is 4 into minus 1 minus 5. Okay, this becomes 1, this becomes minus 4, this is minus 5. Okay, so 1 minus 4 minus 5 is minus 9. Okay, what is 1 minus 9? It is minus 8. Okay, so which is not equal to 0, you have to write this sign. Okay, which is not equal to 0. Therefore, x is equal to minus 1 is not the root of quadratic equation. Okay, so I hope so with this first sum it will be clearer for you how to check whether the values given are the roots of the equation or no. So similarly we'll do sub question 2. So second one says that 2m square minus 5m equals to 0. We have to check with this values. So I'll take substituting m equals to 2. So we'll take this LHS only, 2m square minus 5m. Okay, because m is 2, I'll write here 2 square minus 5 into 2. This becomes 2 into 4 minus this becomes 10. So this is 8 minus 10, which is equal to minus 2, which is not equal to 0. So we'll write therefore m equals to 2 is not the root of quadratic equation. Okay, now let us solve with this, substituting m equals to 5 upon 2. Now RHS, beg your pardon, LHS 2m square minus 5m equals to 2. This is 5 by 2 the whole square minus 5 into 5 upon 2. Okay, so this becomes 5 5s are 25 upon 4 minus this becomes 5 5s are 25 upon 2. Okay, now if you cancel this, 2 1s are 2 2s are, so what you are getting is 25 upon 2 minus 25 upon 2. 25 upon 2 minus 25 upon 2 will be 0. Okay, therefore you can see m equals to 5 upon 2 is the root of quadratic equation. Okay, then okay, so coming on to sum number 5, where the value of x is given and you are asked to find k, and it is given that x is equal to 3 is the root of the equation. Root of the equation, it simply means that kx square minus 10x plus 3 equals to 0 when x is equal to 3. Because x is equals to 3 is the root of the equation, it means RHS will be 0. As we did in fourth one, RHS will be 0. So we have to find k. Very simple. K x square is 3 square minus 10 into 3 plus 3 equals to 0. Okay, so this becomes 9k, 3 square is 9, minus 10 3s is 30, plus 3 equals to 0. Okay, now 9k minus this becomes 30 plus 3, this becomes 27 equals to 0. Okay, so 9k equals to 27. 27 I'll take there. K is equal to 27 upon 9. What is the value of k? The value of k is 3. Okay, then we'll move on to the last sum. Okay, so sum number 6 is when one of the value or one of the root is given and you have to find the other root. Okay, so in that case what to do? It is very simple. I know this is an activity, but I'll be solving this as a sum, so you can fill in the blanks afterwards. Substituting m equals to minus 7 upon 5. They have already given that this is the root. Okay, so I can write 5 minus 7 by 5 the whole square plus 2 bracket minus 7 by 5 plus k equals to 0. If I take this, RHS has to be 0 because this minus 7 upon 5 is the root of this quadratic equation. So this will help us in finding the other root, that is what is the value of k. Okay, so this will be 5 into, this will become 49 upon 25, plus this will be minus 14, 2 sevens are 14, minus 14 upon 5. Okay, plus k equals to 0. Now this becomes 5 ones are 5 5s are 49 upon 5, plus minus becomes minus 14 by 5 plus k equals to 0. Okay, let us solve this. Because the denominator is common, I'll take a single denominator. 49 minus 14 plus k equals to 0. What is 49 minus 14? Is this 35 upon 5 plus k equals to 0. So you can easily cancel this. So 7 plus k equals to 0 we are getting. 7 if I send there, it has to be minus 7. So the final value of k is equal to minus 7. With this we complete our practice at 2.1. So very soon I'll be coming with practice at 2.2. Good luck children. Goodbye.